Okay, I'm going to go through the quiz here for Chapter 8, and then we're going to try it again. I don't know where things got lost in translation. A few of you wrote, I know how to do this stuff on the assignments and in the notes, but didn't when it came to quiz time. So we're just going to go ahead and try it again. So I'll go through this. I want you guys to look through these, and then we'll re-quiz sometime this week. First step here when we're simplifying is to write in factored form. So my numerator, I need to multiply to 32 but subtract to 4, which is going to be -8, +4, because I need different signs because I subtracted, and my bigger number always gets a sign in the middle, divided by t minus 8. T minus 8 divided by t minus 8 is 1. We can split that off and have it be its own fraction, guys. Because it's multiplying, okay, we can take t minus 8 over t minus 8 times just t plus 4. And again, we get t plus 4 as our answer. Then it says, state any restrictions on the variable. Restrictions are always denominator values, and they cannot equal 0. So we're looking for what values of our variable make our denominator 0. Here I have t minus 8, can't be 0. Solve for t, and t cannot equal 8. So my solution is t plus 4 as long as t is not equal to 8, and that's my restriction. Same idea here on number 2. First thing we're going to do is factor. Multiply to 2 subtracts to 1 minus 2 plus 1. Denominator, we need to multiply to 5, subtract to 4. So we're going to go minus 5 plus 1. If you're not sure if that's right, guys, take a second to multiply it back. K squared, good. I have 1k minus 2k minus 1, good. And I have -2. Okay, FOIL it back and just double check. Same thing in our denominator. First, k squared. Outsides plus 1, insides minus 5, which gives me -4. Lasts -5. We're good. Take that second to make sure your factors are right, because it's really important that your factors are right. Otherwise, you don't stand a whole lot of a chance of getting to the right answer here. So, just like we did in the first one, we can simplify. Anything divided by itself is 1 when we're multiplying. Again, guys, we could have rewritten that as k minus 2 over k minus 5 times k plus 1 over k plus 1. We just get 1 here. Anything times 1 is itself. So that only works if they're factors. It only works if they're things that are multiplied. We cannot simplify adding and subtracting the same way. So our answer is going to be k minus 2 over k minus 5. We need to check our restrictions here, and we need to check every denominator piece that we have. So we need to check the k minus 5 and the k plus 1, even though the k plus 1 is factored out. So k minus 5 cannot equal 0. Add 5, k cannot equal 5. And k plus 1 cannot equal 0. Subtract 1, k cannot equal -1. So over here we have k minus 2 over k minus 5 as long as k does not equal 5 or -1. Example number 3 here, product in simplest form. Product means multiply, and when we multiply fractions, we go straight across. We combine them into one fraction. Multiply our numerators together, multiply our denominators together. So right now I have 3 g to the 5th h to the 5th over 10 h squared 10 g squared. And remember, those are all just multiplied together. Things that I have that are the same are my g's. So when I divide powers with the same base, I subtract exponents. Same thing with my h's. H to the 5 minus 2 gives me h cubed. The other way you can think about this, guys, is I'm going to take 2 g's from here. So I'm going to take 2 from here and have 3. I'm going to take 2 h's from here. And I take 2 h's from here and have 3. Okay, if I had written them all out, anything divided by itself is 1. Anything divided by itself is 1. G cubed. Our number parts, then, we can just multiply across. I'm going to have 3 in my numerator. 10 times 10 in my denominator is 100. So my final answer is going to be 3g cubed h cubed over 100, as long as our restrictions here, check every variable in your denominator. Our variable factor here is just h, so h cannot be 0, and g cannot be 0. So as long as h is not equal 0, and g is not equal 0. 4. Same idea here, but again, I'm going to factor first. In numerator, I'm going to have y multiply to 6, but subtract to 1, minus 3, because 3 is bigger, plus 2. Here in my denominator, I'm going to factor out a y, so I'm left with y plus 1. We always want to factor first, just to see what we have and see if we can simplify anything before we go further. Again, we can multiply straight across with fractions. So right now what I have is y squared times y minus 3 times y plus 2 over y minus 3 times y plus 1. Y out of y squared leaves me with just 1. And I have y minus 3 and y minus 3. So I'm left with y over y plus 2. Sorry, y times y plus 2 over y plus 1. We have to check our restrictions here. Check every denominator. I have y minus 3. I have y plus 1. And over here we have the same combination, so we're good. Y minus 3 cannot equal 0. So y cannot equal 3. I have y cannot equal 0. And I have y plus 1 cannot equal 0. So y cannot equal negative 1. So y cannot equal 3, 0, negative 1. And again, it doesn't matter that 2 of those factored out. Doesn't matter. They have to be there to start with. Okay, anything that we have in a denominator ever, because we couldn't have multiplied these two if we'd have had a 0 for y, even though it's not our final answer. Same thing, this fraction right here can't be a fraction if y is 3. So we have to be careful and account for every variable in our denominator. Five, again, I'm going to go ahead and factor before I do anything. A plus 2, a plus 1, a minus 5, nothing we can do there. But the a squared here we can. We need to multiply to 15, add to 8. Minus 5 and minus 3. Same sign, both negative. Again, FOIL and check if you want. A squared minus 3a minus 5a gives me minus 8a and plus 15. Negative times a negative is positive. So it's easiest here to do restrictions on your variable, and a lot of times it's easiest to do that part first regardless, but especially when we have division. So here, a minus 5 cannot equal 0. Then I have a minus 5 again, and a minus 3 cannot equal 0. So a cannot equal add 5, add 3, 5 and 3. Okay, now when we divide fractions, we multiply by the reciprocal. The first one stays exactly as written. We don't change our first rational expression. we multiply by the reciprocal of the second, which means the bottom goes to the top and the top to the bottom. So I'm going to have a minus 5 times a minus 3 in my numerator, and my denominator is going to be a plus 1. Again, when we multiply fractions, now we multiply straight across. So I have a plus 2 times a minus 5 times a minus 3 over a minus 5 times a plus 1. Common factors, again, factors, things that are multiplied, and only if everything is a factor can we simplify. Divide out, and I'm left with a plus 2 times a minus 3 over a plus 1. As long as I have another denominator now, so I need to check that. A plus 1 cannot equal 0, so a cannot equal negative 1. Do a real quick check. Do I have every denominator accounted for? Yep, 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 yep. All my denominators are accounted for. So a cannot equal 5, 3, or negative 1. If you wanted to multiply these out, you sure can. You don't need to. You could have gotten a squared minus a minus 6 over a plus 1. That would have been just fine too. I don't have a preference. Six here, we're dividing again. Difference of squares, x minus 4, x plus 4. In the denominator, I need to multiply to 6, add to 5, x plus 2, x plus 3. I saw a lot of 6's and 1's there. Just be careful. This is another one of those where just real quick double checking. Do I add to 5 and multiply to 6? Yep. Perfect. Okay. Multiply to 4, add to 5. So I have plus 4 plus 1. And in my denominator, I have minus 4 plus 2. Multiply to 8, subtract to 4, 4 and 2, bigger number gets the negative because the sign in the middle is negative. So I'm going to check my restrictions here. X plus 2 cannot equal 0. X plus 3 cannot equal 0. X minus 4 cannot equal 0. And x plus 2 cannot equal 0. All of my denominators. Which means x cannot equal negative 2, x cannot equal negative 3, x cannot equal positive 4, x cannot equal negative 2. And we already had the negative 2 here. Okay? Now, we divide, and when we divide fractions, we multiply by the reciprocal, which means we keep our first fraction exactly as it is. Okay, we switch from division to multiplication, and we flip our second fraction. Bottom goes to top, top goes to the bottom in reciprocals. Numerator and denominator flip. So my numerator now is going to be what was my denominator, and my denominator is going to be what was my numerator. Now, with fractions, we can multiply straight across, multiply our numerators, multiply our denominators, which means check your numerators. Is there anything I can cancel? I have an x minus 4, nothing in the bottom. An x plus 4, I can cancel. X minus 4, nothing in my denominator. X plus 2, x plus 2. Check your denominators for restrictions. X plus 4 cannot equal 0, so x cannot equal negative 4. And x plus 1 cannot equal 0, so x cannot equal negative 1. We get x minus 4 times x minus 4, or squared, over x plus 3, x plus 1, as long as x is not equal to negative 2, negative 3, 4, negative 1, or negative 4.